All right, hello and welcome to Introduction to Python, the second phase of Geography 473-673 here at University of Delaware. I'll be your professor, instructor, James Simpkins. You can just call me James, and just a little background on myself. I am a satellite meteorologist slash programmer here at the university. I work for the Center for Environmental Monitoring and Analysis, and I am in charge of the University of Delaware Satellite Receiving Station. So I code a lot, and especially with Python. And the reason that I'm teaching Python and the reason why I use it so much is because it is the most popular programming language in the world. And with great reason. I mean, Python, there's just so much that you can do with it. Just about anything that you want to do, from website management and creation to data mining and machine learning to geospatial sciences. We can just do just about anything with Python. And for this course, we're going to be covering some different topics for geospatial sciences in particular. Now, for those of you who have taken my courses before, it's very hands-on, it's tutorial based. So all that you'll need for this class is right here at the Introduction to Python, or in this case, the Geography 473-673 website. So you can ignore this introduction to our stuff, so we'll just focus here at Introduction to Python. And so we have 7 weeks together, and then so we'll do 7 different tutorials, and at the end of each tutorial, we do an assignment that just covers and practices, reinforces some of the things that we coded in the tutorial. So we have 7 of those tutorials and then a final project, which I'll get into at a later time. But so all you need to do is follow along with the tutorials, code up, and just read intently, closely, code up, practice your skills, and then use those skills to accomplish an assignment. Once that assignment is done, you'll typically only be required to submit a PNG or some sort of image to Canvas, and that is how I will grade you. If you can submit an image with something that makes sense and follows the assignment, then I know you have the ability to code. I don't necessarily care about how you're coding. We don't have the amount of time necessary enough to go through coding practices such as organization and just general efficiency. I wish we did, but unfortunately we do not, and that is why I only require you to turn in just evidence that you can code. And the evidence that you need is a PNG or just a graph in most cases. So this is the course website, and all of this course is really built on tutorials that are housed on GitHub. So down here, I still have the R stuff up, and this will change over in a couple days over to Python. But the syllabus is the same exact thing. And all of this is run through GitHub. And real quick, just for those of you who don't know, GitHub is the world's largest coding repository. This is where programmers from all over the world, all kinds of different disciplines, store their code and share their code. And this is where I store everything for the class, all the code necessary, and we also have all of our data sets here that we'll need for the class. We have our course website link and then the syllabus. And so the entire course is built on these tutorials and the final project. So that's pretty much your entire grade, just accomplishing the coding assignments and then the final project, which again, we'll get into that a little bit more. So all the entire goal of this course is really just to learn Python. And as long as you are making progress with the tutorials and keeping up, I guarantee you that you will get something out of this course. You will have an understanding of Python, at least at a basic level, after taking this course, and that's my goal. So all I ask for you to show as a student is just that you are learning Python. I understand that there's going to be different levels and rates at which you learn, because with coding and learning coding is very exponential based, meaning that the longer time you spend with it, the more you understand it. It's very similar to other things, but I especially notice an exponential curve with Python, where it's, in coding in general, is just that it's a slow progress at first, but the longer you spend with it, the faster progress gets. So it's very much an exponential curve, and I just expect you to have proficiency in Python data management capabilities, experience with quality control, quality assurance, experience plotting and representing geospatial data sets, and the ability to apply common data analysis and hypothesis testing tools for spatial data sets. So we're going to be covering all of these in Python, and I just really hope you know that just through accomplishing this short course and really trying hard to adopt the mindset needed to code in Python, you will open up doors down the road for yourself, whether it be future graduate school or future academia opportunities, or public or private sector jobs. You can get a job just by knowing Python. And so I really hope that you get enough out of this course that you feel confident to put this on your resume, whether that be for a graduate school application, a PhD application, or public or private sector. So again, the structure of this course is very just tutorial based, because I believe that coding is a skill to be practiced rather than a theory to be learned. We will spend minimal time lecturing. I will run through the lectures, which will be short and where I just kind of cover the tutorials and talk about different things as I normally would if we were actually in the classroom. So there's some extra textbooks down here. I might be adding to this a little bit, and then we have a general guideline. And again, we're really just doing one per week here. And it's really just one little tutorial per week. We have in the first couple, we kind of run through some pretty quickly, but these are pretty basic. So we have week 1, which is it's October 5th and October 7th. We're going to be covering Introduction to Python, and then cover Python modules, syntax, classes, data types. And all of this is just under week 1, and then we'll cover NumPy and Matplotlib in week 2. And then X-Ray, Pandas, CartoPy, MetPy, SciPy, and the like. And then the final class is going to be 12/9, and again, these are really just final project days where I just expect you to accomplish a final project, which we will get into. So without further ado, let's go back to the course website and let's get everything installed. Normally, we would be in the classroom and all of this would be installed for us on the computers, but in this case, we'll need to install everything we need by ourselves. Now, the way that we're going to be able to install Python is a Google search and a download. This is free software. Everything about Python is 100% free, just as R was for those of you who took the 1 credit here before. So what we're going to be doing is downloading Python, and specifically we're going to be downloading the Anaconda installation. There's a lot of different installations of Python because Python suits a lot of different needs for a lot of different types of coding and a lot of different endeavors. So there's a plethora of different Python management pieces of software out there that help you understand your Python IDE, install packages, and so on and so forth. We're going to be using Anaconda. So the first thing that I'm going to do here is I'm going to click on Installation and Setup, and let's get set up here to give us everything that we need for this class moving forward. And so what we're going to do is, first things first, we don't have Anaconda Navigator installed on our local machines yet, most likely. So you're going to need to install Anaconda Navigator. And the way that we're going to do that is I'm just going to type in Anaconda Download into Google. Click the first link, Individual Edition. Go down to Download, and it brings you down here to Anaconda Installers. And I just installed this for Mac OS. I'm on an Apple machine, but if you're on a Windows machine, just figure out whether or not your machine is 32 or 64-bit. Download the appropriate one and install. It's all of this stuff with Python is free software, and it's very light. It is not going to take up a lot of room on your machine, so don't worry if you're limited for space. This is not going to take up much space at all. It's not going to slow your machine down until you're crunching big data. So don't worry about that, but just go ahead and download that as you would with anything else. Now what we're going to be doing is once we have that downloaded, we need to open Anaconda Navigator. So for me, I'm going to come up here to Applications, and I'm going to find Anaconda Navigator and open that up. So Anaconda Navigator just houses everything that we need to run Python and be successful with it. So it has a list of different IDEs or integrated development environments. All these are just applications that make coding in Python easier. It makes it more human readable and human editable so that we can run our Python code. So for those of you who took my R phase, you see RStudio is an option down here. You can actually run RStudio within Anaconda Navigator. Now you can't run it for Python, but you can run it with R. So Anaconda Navigator is really trying to branch out to other languages and just for all data science purposes. But we're going to be using Spider as our IDE. So Spider is, in other words, our RStudio for Python. So again, Spider is our application that's going to make running code with Python easier. So all I'm going to do is I'm going to launch Spider, and this is what we're going to need to do every time. So it's launching Spider. It might take a little while, and here we go. Okay, we don't necessarily need Kite. You can install it if you want, but anyway, this is what Spider looks like right here. So what we see is that we have a coding console over here. So this is where we execute our code. We have our script over here. This is our Python script. This is our canvas, and then this is the console right here where we can actually go and execute code. Then up here we notice we have a variable explorer, help, a plots window, and files. And so if I actually come up here and I run all this code, so I just ran all of that, and I come over here to plots, and boom. I just ran that code and just ran my first Python code. Now, you don't have to do this right now by any means, but just to give you a little heads up, and I'll go into this in more detail in a later video, but this is Spider. This is what we're going to be using. This is how we're going to be using Python. This is our application. So notice that at the top of the Python script, just like we did in R, we need to load in packages. Now, these are also called modules in Python. So a module or a package is all it is pre-written code somebody wrote ahead of time so that you didn't have to recreate the wheel. So imagine modules or packages as just tools that you go to buy. So in other words, all we're doing right here when we load in NumPy or matplotlib is we're saying, okay, I want to bring this toolbox, then I want to use different tools down here from that toolbox. Now, in order to install these modules or packages, we need to go back to Anaconda Navigator. So what I need to do is I actually need to come over here to environments. Now, I have a lot of environments here because I use a lot of different pieces of packages that work together in certain circumstances. You probably only will have one, and that is base. So the first thing to do is just it's a good common practice, and that's to create a new package. So we're going to create a new environment, and we're going to say, look at all these different versions of Python we have. We only have Python 3.8, that's fine. And we're going to just name this one Geog 3.8 for Python 3.8. I'm going to create that, and then right down here, my new environment is being created. So this is a very nice tool in order to install different environments. Now, why would you want different environments? The reason you need different environments in Python is because there's so many packages out there. There's so many packages and modules out there that some of them are not compatible with each other. packages have what's called dependencies. And dependencies are other packages, most cases very basic core packages to getting anything done in Python that they rely on. So in other words, we're going to be covering some packages such as Xarray and Pandas who have dependencies. They are dependent on very basic packages like NumPy and Matplotlib. So these are packages that have already been installed. Now, what I'm going to be doing right now is I'm going to be running through an example on how to install a package that you need. So, in this example, I use CartoPy, and I'm installing CartoPy, and that's something that we might need to install. So let's go ahead and let's go over here and let's install CartoPy. So I'm going to search packages, CartoPy. And notice I don't have this installed right down here. So that's not installed yet in my Geog38 environment. And once again, we need to keep what we install over here separate from these other environments because we have packages specifically for this environment that we might need, that might not be compatible with other ones. So let's search not installed. And then let's just go down to all. So what I just did is I updated the package index and metadata just to see if this would pop up here for us, because otherwise we're going to need to install this a different way. It's taking a second here, and remember that this is free software, that's why it doesn't work super fast. So after we updated our index here, that would allowed us to pop this open. So this is our search results for CartoPy. So all we're going to do to install this, which is a library for cartographic tools in Python, I'm going to select this and come down here and hit apply to download it. So it's just going to solve the package specifications, and what that means is it's going to install dependencies for us. So all these other, look at all of these other packages that we're installing just by installing CartoPy. We're going to click apply, and all of those packages are dependencies. So those are other packages that CartoPy requires in order to run successfully. So it's installing everything right now, and it's telling us what it's downloading, and so all of this is contacting different Python repositories that are online based, downloading those dependencies and packages so that we can use these tools to code in Python. So while that's working, I'm going to clear that out, and I'm going to come over here and come back to installed. And what we'll see here is that once this all finishes up, CartoPy, along with these dependencies, will pop up here as installed. And so I'm just going to update my index while it continues to do that just to see how everything's going. And it's still installing. It's going to wait until everything is done downloading before it updates this specific index of installed packages. So this is a pretty, not a large package, but there's a lot of dependencies here, so there's a lot of different things to download. But again, we're talking in the magnitude of kilobytes, so even though we're downloading a lot of different things, they're not big. They're not taking up a lot of space. And now we finally finished downloading and installing, and look, we went from 16 packages to 107. and here's CardoPy right here. So we installed all of these other packages which are necessary to run CardoPy. So that's awesome. We just have all of these ready to go at our disposal. And that is how you would download something that actually is searchable. Now, there are going to be circumstances, however, where something does not show up under not installed. So when we search here, it does not installed. It does not show up. And so what I mean by that is sometimes let's go ahead and let's just assume that a package that we want, metpy, is not here. I'm actually really surprised that this is here right now because typically this kind of package is only used by a select number of people and it wouldn't be up here, but that's great that it is. In the case that a package you want to install is not available, we need to install by hand. We can't just point and click using this. So I'm going to click under my environment that I'm working under right now. Then I'm going to go to Open Terminal. Now, what that did for me right now is it opened up on my machine my terminal, and this is how I talk directly to my computer. And notice that it loaded up for me Geography or Geog38. So that's my Anaconda environment right there. Now what I want to do is I want to come over here to Google and I just want to type in Conda install metpy. And I'm going to come down here, come down to the Anaconda Cloud link. So this is where we come to get the functions that we need and the commands that we need in order to install. So what I'm going to do here is I'm going to select this version. Notice that there's a number of different packages available, and so we have the base one, we have one that is from 2019-01 and one's from 2020-03. We have some different versions of metpy. The reason that this happens is because, as I said before, people have different versions of Python, people have different versions of dependencies, and this creates headaches. And so this is why I wanted to cover installation of packages right now, because this is what makes Python annoying. Python is an amazing, amazing tool. This is the one annoying part, where installing packages is not quite as easy, nowhere near as easy as it was in R. But again, the reason that it is this way is because there's so many different packages that you can use. It's so large, it's such a big universe that we have many different channels, many different versions of code that works with some and is compatible with some but not others, and so on and so forth. We're going to select this link. I'm going to copy this command right here. I'm going to come back over here to my terminal. I'm going to click, paste that in there. And what we're going to do now is this is going to run through exactly what we did over here, where we selected CardoPy and installed it. Only this is the way to do it manually. This is the way to do it by hand. So what we're doing now is we're contacting Anaconda Cloud using this link right here. It's going to check out our environment and say, okay, like what do we have going on right now? What kind of dependencies do you have installed? What kind of versions of packages? Is this compatible with metpy or not? So it's going to check out our environment and see it. And now we notice a couple things here. So take a look at this. You can ignore these warnings. It might not even pop up for you. This is what you need to pay attention to. Downloaded. The following packages will be downloaded, the following packages will be installed, and the following packages will be superseded. We never want to downgrade packages. If you, in this case, everything looks good, but in other cases you could have something pop up that says the following packages will be downgraded. We need to be careful if we do that. We probably shouldn't do that because downgrading packages can be bad. Superseded, especially something like this, CA certificates, this doesn't matter. But if, for example, we had a downgrading of pandas or downgrading of X-ray or something like that, we would want to stop and double check, make sure that it's okay. Because what happens is if you downgrade a certain package, that is changing the dependency of another package. So all we're trying to do is we're trying to keep one collection of packages that works together and plays nicely together. That is why we have individual environments. In this case, everything is good to go. We're just installing new packages. Nothing is being downgraded. So proceed. I'm going to hit Y for yes, hit enter, and it's going to download everything that we need. So it's downloading all of these packages and installing them for me. So there's MetPy, and then here's all of the different dependencies. And just like that, we're done. We are good to go. So now if I come back over here, I'm going to go over to installed. I'm going to hit X here. I'm going to update my index so I can update this library of installed packages that we have. And it's loading in these extra packages now. And in a second, what it will show is 118 packages now. And if we scroll down a little bit, here is MetPy right here. So that's awesome. Everything installed, everything was happy, and we'll just come over here and we'll just double check. You don't have to do this, but import MetPy. What we need to do is if we're going to use this, what we would need to do is reload. And I'm going to say open with Python. And this is the manual way, and I'm just double checking. You don't need to do this. Import MetPy, and it imported successfully. So now the way to do this longer way is if we come down here and we need to reinstall Spider. And the reason that we need to do that now is because we are using Geog 3.8. So we had Spider installed for a different environment because when I first opened this up, I was under my base environment. We created a new environment, and thus we need a new version of Spider that is compatible with Geog 3.8, this environment that we just made. Once Spider is installed, we'll be good to go, and we should be able to load in all the packages that we need.